everyone, my name is Syalomita Sibara from Pharmacy Samratulangi University. In this video, I will explain about dispersion systems, which consists of definition, basic classification, types of dispersion systems, and properties of colloid systems. For further video about dispersion systems, you can watch this video until the end. The first submatery is definition of dispersion system. Dispersion systems are systems containing at least two phases, with one phase being dispersed in the other phase in the form of small particles. The substances that are dispersed are referred to as the dispersion stage, while the one in which they are dispersed is called the dispersion medium. For example, starch placed in hot water undergoes a dispersion system. Here water is dispersing medium, while starch serves as a dispersing agent. A dispersion system can be defined as a solution or mixture of two different substances, but having the same form. A characteristic feature of a dispersion system is the presence of a solvent and a solute. The second submatery is basic classification. A dispersed phase is referred to as the dispersion ratio or dispersion phase. The phase whose continuity remains preserved is referred to as the dispersion environment. Dispersion systems may be classified using several criteria, namely, first, state of matter of the dispersion environment and the dispersion phase. Second, size of particles of the dispersion phase. And third, structure of the dispersion phase. Classification based on the phase state of matter is summarized in the following table, which can be seen on the screen. In most systems, the dispersion ratio exists simultaneously in a continuous distribution of different particle size, and the system is termed polydispersion. Based on the dispersed ratio structure, dispersion systems may be classified as: first, systems with isolated particles called sols. Second, systems with an interlinked structure of the dispersion phase forming a net structure in the dispersion environment, which are called gels. When describing the properties of dispersion systems, we may characterize them using other criteria too. Next submatery is types of dispersion system. A dispersion system is thus a mixture of the dispersed phase with the dispersing medium being mixed in a uniform manner. Dispersion systems are divided into three groups, including first, coarse dispersion. Coarse dispersions can also be called suspensions. A suspension is a heterogeneous mixture of a dispersed stage and a dispersing medium. A clear distinction can be made between the dispersed phase and the dispersing medium. In a phase, the dispersed is usually in solid form, whereas in the dispersion medium, it is in liquid form. The dispersed phase has a particle size of more than 10 to 5 cm, so it can see the sediment. An example is a mixture of water and sand. Second is colloidal dispersion. Colloidal dispersion is a dispersion system between fine and coarse dispersion. The mixture in a dispersed phase with the dispersion medium is colloid appears homogeneous. In fact, in colloidal dispersion are heterogeneous mixture. This becomes apparent when the colloidal dispersion can be observed using an ultramicroscope. An example is agar-agar. Third is fine dispersion. Fine dispersions are also referred to as a real solution or molecular dispersion. In a real solution, a homogeneous mixture is formed because the larval phase is dispersed with respect to the dispersing medium. This homogeneous mixturing is also called a solution. In the dispersed phase, the solution can be solid or liquid, while the dispersion medium is a liquid. An example is solution of tea and water. The last submatery is properties of colloid system. Systems containing colloid particles are in some properties different from systems which are homogeneous or composed of macroscopic phases. First, light scattering. If light passes through a system containing colloid particles, part of the light is scattered and consequently the ray passage through the environment can be observed. For the intensity 1 of light passing through a dispersion environment is written according to the one on the screen, which is compared with the relation. Second, sedimentation of colloid particles. Another effect observed in colloid systems is their gradual sedimentation and attainment of a sedimentation equilibrium. The rate of sedimentation in gravitational field V for the sedimenting spherical particles of the radius r is given by the following relation shown on the screen. Third, membrane equilibria. Different properties of colloid systems are also evident when we observe those comprised of two subsystems separated by a semi-permeable membrane. The osmotic pressure is given by a relation analogous to that for molecular solution. If the systems contain a low molecular electrolyte Ka in addition to a high molecular electrolyte Kr whose anion are thus not pass through the membrane, a different equilibrium is established in the system. It is influenced by the activity of the electric charge of ions, and it is known as the Donan equilibrium. The equilibrium is conditioned by equal activity of the electrolyte Ka in both subsystems, or denoted by the subscript 1 and 2. That's my explanation about dispersion systems. I hope this video can help you all, guys.